Hi, and congratulations, you have made it to the final video for Chapter 5A. This section of notes will also go into the factoring section of your foldable. And one thing that I want you to do is copy down this table. It's going to have some formulas that are going to help you. Now, we have previously talked about how to factor out the greatest common factor. So it's up to you whether you want to write down this formula. We already have some examples in your foldable, so as long as you know what you're doing, you don't really have to copy down that formula. And we've also looked at a couple examples of factor by grouping, which use 4 terms or 6 terms. So those two formulas, it's up to you whether you want to have them in your foldable or not. But what you definitely do have to write down is the factors and the factoring formulas for 2 terms, which includes the difference of 2 squares, the sum of 2 cubes, and the difference of 2 cubes. And for 3 terms. Now, you don't have to copy down these perfect square trinomials, because we're going to cover these formulas when we talk about how to factor general trinomials, and those are just a special case. So the bulk that you need to write down are these 3 formulas and general trinomials. So pause the video and copy those down. All right, so now we are going to look at a few examples of these factoring techniques. So the first thing that we need to do is we need to look at this term and see if there's anything that all terms have in common. And there isn't anything that I can factor out using the greatest common factor. So now I look and I see that it has 2 terms. Well, I have 3 formulas for factoring 2 terms. I need to first decide whether these are cubes or squares, and then decide whether it's addition or subtraction. Since C and D are both being cubed, I can rewrite this as C times D cubed. Plus, and I can rewrite 27 as 3 cubed. So that's enough information for me to decide that I have 2 factors that are being cubed and it's addition. So I need to use this formula that I have copied down from above. In this example, my A is going to be replaced by CD and my B is going to be replaced by 3. So I need to start by making 2 sets of parentheses. The first set's going to be smaller. The second set's going to be a little bit longer because I'm going to have 3 terms in it. So I write down A plus B, which in this problem is going to be CD plus 3. And on the next example, or in the next part, I take A squared, so that's CD squared, or C squared D squared, minus my A times my B, so that's going to be CD times 3, so that's 3CD. And then the last part of the formula is B squared. So in this example, that's 3 squared, and 3 squared is 9. And this symbol is plus. So this is what you get when you factor out C cubed, D cubed plus 27. And if you wanted to check, you could multiply CD through all 3 parts over here, and you could multiply the 3 by all 3 parts over here. Once you cancel out some of your factors, you would be left with C cubed, D cubed plus 27. So now let's move on to this next example. I have 16W squared minus 169. So looking at these, 16 only has factors of 2, and 169 only has factors of 13, so there is not a greatest common factor. So now, since it has 2 terms, Are they squares or are they cubes? And this 2 on the W leads me to think that all of this can hopefully be written as the difference of 2 squares. So I'm going to try and write 16W squared as 4W, and then I squared on the outside of that, minus 169, which is 13 squared. So now I can look up above and get the formula that I need. They are both squares. They are both squares, and it is subtraction. Let me just take a pause right here and point out that the only formula that I have for squares is subtraction. So if this had been a plus sign, I would not be able to factor this, and I would just write down the fact that it is prime. But since it's minus, I have 2 sets of parentheses, and this time each set of parentheses is going to have 2 parts, so they can both be about the same size. In this problem, my A is 4W, so I write that at the beginning of both sets of parentheses. So I'm going to write 4W and 4W. Then in this problem, B is going to be replaced by 13, and that goes second in both sets of parentheses. And looking at this formula, one is plus and one is minus, and it doesn't matter which one's which, so you just put a plus sign in one of them and a minus sign in the other. And the reason that this works out to give you the 16W squared minus 169 is if you were to FOIL out this example, you would have 16W squared from the first part, then you would have negative 13 times 4W and positive 13 times 4W, and those would cancel out. Then at the end we have 13 times negative 13, which gives you the negative 169. So you can see how this works, and that's why this is the formula when you are factoring the difference of 2 squares. Alright, let's look at example number 6 for this section of your foldable. And we have m to the 6th minus n to the 6th. Now, if you look at 6, that's kind of an interesting number because it can be rewritten as squares or cubes. And we want to start out by rewriting it as the difference, because it's minus, of 2 squares. So I'm first going to rewrite m to the 6th as m to the 3rd squared minus n to the 3rd squared. Using the formula from up above, let me move this out here. You can see that I take the square root of each part, so a minus b, break it up just like I did in the last example into the 2 sets of parentheses. So I'm going to have m cubed minus n cubed and m cubed plus n cubed. Alright, so now I have broken these down into my separate sets, and if you look at each of them, these are the difference of 2 cubes, and this set is the sum of 2 cubes. So I need to use those formulas from up above, so let me get these 2 formulas that we're going to use. Hang on a second. Let me pull this other formula out. And now we're going to apply that to what I have here in these sets of parentheses. So m cubed minus n cubed. That's going to follow this example down here. So I have a small set of parentheses that I write exactly what's here without the cubes. So I'm going to write m minus n. And here's the main thing. Let me point out the main thing that's different between these two formulas. The one that's plus in the small set of parentheses is plus, then it's minus, and the last set is always plus. In the other example, where it's minus, the first set of parentheses is minus, then in the second set, it's plus, the opposite of that one, and then it's also plus back here. So the last set is always plus. The first set of parentheses matches what you have in your problem, and the second symbol is the opposite. So now I can use that to finish factoring this part. So it's going to be m squared. And the opposite symbol from here, so it's plus m times n. And then the last symbol is always plus my n squared. And that's what I get from here. Now, to factor the other part, I'm going to use the sum of two cubes, and I'm going to take this and break it up. So I have another small set of parentheses, and then I have a big set of parentheses. And I'm going to take m plus n, because that's like the original problem. And then I'm going to take m squared, and I use the opposite sign, so this time it's minus m times n. This one's always plus n squared. So this is what I get from the second set. And your answer is all of this together. And I know sometimes when you're factoring, the problems they can look a whole lot more complicated. But in a few chapters, in the next few chapters, we are going to be using factoring to help us simplify some problems. So this is a technique that you really need to be good at, because it's going to keep reoccurring in future chapters. And finally, we have this final example. Now, if you look at it, there are no greatest common factors, but this time we have 3 terms. And this is going to be something that we're going to do a lot of, is factoring 3 terms. So here is this technique. When I was in high school, they just taught us how to guess and check. And that was good if you were good at guessing and checking. But since then, they have come up with this technique that will help you factor. You have to look at the numbers with the coefficients, so you always have to write it x squared, then x, and then the number that's by itself. The coefficient, or the number in front of x squared, we're going to refer to as a. The next part, including this negative sign, so negative 13, is b, and the last number is going to be referred to as c. So we need to make a t-chart to help us in this factoring. And the way the t-chart works is you take a times c. And then on the other part, you're going to have b. So a times c, over here in my example, 5 times 6 is 30. And my b is negative 13. So what we have to try and find are 2 numbers that multiply to give us 30, and when you add them, they give you negative 13. Now, if you're not really sure what we're going to do, or how, if you can't see those factors right away, you can list out all the factors of 30. So we have 1 times 30, But when you add that, you get 31, not negative 13. We have 2 times 15. And when we add that, we get 17, not negative 13. We can take 3 times 10. When you add that, you get 13, but we are looking for negative 13. So I'm sure some of you are already saying, well, let's use negative 3 times negative 10. And when you add that, you do get negative 13. So this is the set of factors that we are going to use as we move forward in this problem. So if I go over here, I need to rewrite, instead of having 3 terms, I want to rewrite it so that I have 4 terms. Because in the last video, I showed you how to factor 4 terms, and you've already had a homework assignment over that. So I'm going to leave the first term alone and just bring down 5x squared. My negative 13x, this is what I want to split up into 2 groups. So instead of just combining my like terms and having negative 13x, I'm going to use these numbers over here and split it up into 2 groups. So I have negative 3x and I have negative 10x. And you can see that if I were to combine like terms, I would get the negative 13x. And then my 6, I'm just going to bring down plus 6. So now I've turned this problem into 4 parts instead of 3 parts. And we've already talked about how to factor this by grouping. So I'm going to take my first 2, put them in parentheses. I'm going to take my last 2, put those in parentheses. And I'm going to put a plus sign in between here. That's why I moved this minus sign in here to make it negative 10x. Looking at my 2 sets, 2 terms in the first set of parentheses, the only common factor that they have is x, so I pull that out front. That leaves me with 5x minus 3 plus, and these 2 have a common factor of 2. So I'm going to pull out 2, and that leaves me with negative 5x plus 3. Now, if I look at what I have in my 2 parentheses, I have 5x minus 3, and I have negative 5x plus 3. Well, these 2 are similar, but my signs are different. So I'm going to change this to plus, this to minus, and I can do that by moving the negative sign out front. So now my parentheses match up, and I have 5x minus 3, and that comes from both of these that I have underlined in black. And then I'm going to underline the parts that I put out as my greatest common factor in red and rewrite them down as x minus 2. And now 5x squared minus 13x plus 6 has been factored into 5x minus 3 and x minus 2. And you may want to just indicate or make a note that this is in this video, because factoring a trinomial is going to be something that you really need to get good at and practice. And if you have any questions, I can go over those in class.